Hello and welcome to a quick tutorial on Lab 9, 1 in a billion. I've had a couple questions about how to do this table and calculate the mass of a million pennies. So let's start with table 1. We told you the mass of a million pennies is 2.5 grams. Notice we say it's in grams. And so to get the mass of 10 pennies, you take the number of pennies times 2.5, and that would be 25 grams, for example. Okay? And then you're just going to multiply it out the rest of the way down. Now, when you get that number, that's going to equal X number of grams. The next question asks you, what is the mass of a million penny in kilograms? So you're going to take this number and simply plug it into this equation, and that will equal the weight of a million pennies in kilograms, and you'll take that number and divide it by 1,000. So then you want to look up the weight of a male giraffe in kilograms, and you can just do that in Google. And then you're going to take how many pennies, how many male giraffes. So again, take this number, X kilograms, down to this equation. So to get the weight, the comparison of male giraffes in kilograms, you're going to take this number that you calculated, X kilograms, down to here, and divide it by the weight of a male giraffe. Whatever you find online, and of course you want to show your math when you do that. The model of your car and truck, you're going to look up the curb weight. It's probably going to be given to you in pounds, but if you Google a conversion of pounds to kilograms, you can quickly find that and convert it to kilograms. And then again, take this number here and bring it down and compare it to the mass of a million pennies. You want to compare that mass down here and tell me if it's less than, more than, or equal to the weight of your car and truck. And then activity 2, preparing a 1 part per million solution. These are the air quality standards that you're going to look at, and notice they're in 9 parts per million and 53 parts per billion. Well, we want to see if you can see that, and we're doing this with this experiment right here. And basically you take an ice cube tray like this, and I'm going to make this a little bit bigger. And I'm going to number the wells 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for example. And however you number them, it's up to you. And then I'm going to take 10 drops of dye, and I'm going to put it in well number 1. That's a little bit too dark. I'm going to put it in well number 1. So that represents my 10 drops. Okay, 10 drops. And then I'm going to take water, and I'm going to get a little bit lighter color to represent water, and I'm going to put 9 drops of water in the rest of the wells. And come down using a clean pipette. So that's 9 drops of water in the rest of them. And then I'm going to start doing what's called a serial dilution. I'll take a clean pipette and I'll transfer 1 drop from this well into this well, just 1 drop. And what you'll notice is, and I'm going to erase a little bit here, that 1 drop that I took, what's going to happen is it's going to get diluted by the 9 drops of water, and it's going to be a slightly lighter color red. And then I'm going to clean my pipette with clean water. That glass of water that you have, it's nice and clean. And I'm going to take 1 drop of that after I mix it, and I'm going to put it in the next one, and it's going to turn an even lighter shade of red after I mixed it because I'm diluting it again. Now, every time I'm diluting it, this dilution right here is by a factor of 10. And this is diluting it 10 more times. okay, that we're doing it, and we're always going to take a drop. So I would take a drop from there and put it into the next one drop, and then you'll notice that it'll even start to turn a lighter shade of pink as you do this, and you're going to continue all the way down, and eventually, and I'm not going to say where, but somewhere in here, it should not start to look pink anymore, and that's why it's so important that you have that ice cube tray. Now, it tells you to record your data over here in this table. So when you record your data, is the color visible? You're just going to say yes, yes, and then based on your ice cube tray, if you no longer see it, say by well 4, no, 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 you would just write no for the rest of them. But even when you stop seeing it, you want to keep transferring drops. Now, we're also working on calculating this. So the fraction of the first one was 100%, so it was 1 to 1. And to convert it to a decimal, you divide 1 by 1, and that equals 1. And then you take 1 times a million, which is parts per million, and that equals your number. And then you're diluting it by a factor of 1/10 each time. So that first drop that you transferred from well 1 into well 2, remember we took 1 drop? That represents a 1/10 dilution. So 1 to 1 times 1/10 equals 1/10. And then 1/10, you take 1 divided by 10, that gives you 0.1. Now to get this number, you're going to take, you took this number and multiplied it times a million, and that's basically what you're going to do here, 0.1 times 1 million equals, and you're going to find out that you're going to lose a 0, and you're just going to count out what's left. That's 5 zeros, so I'll do 1, 2, 3, 4, and I'll put 5 zeros, and then I'll come back, and it drops by a factor of 10. And the next one you're going to do the same thing, except you're going to take the 1/10 over here, because again, you took 1 drop from here and put it into well 3, and you're going to take 1/10 times, you diluted it by a factor of 10, so 1/10. You're always going to multiply by the same number, 1/10. And 10 times 10, all right, is 100. So that's 1 over 100 is what it is. And then you would take 1/100th, convert it to a decimal, and 1 divided by 100 is 0.01. Now at this point, I recommend that you change the formatting to left justified in this table over here so you can see that you're going out. So basically I'm getting smaller by a factor of 10, and it changes it to 0.1, and then another factor of 10 changes it to 0.01. And then I would take 0.01 times 1 million. And that's going to knock two zeros off at that point. So now I have 4 zeros, because every time you have a decimal point, knock out the same number. So that would be 4 zeros, 1, 1, 2, 3, 4. And that takes it down to 10,000. Again, you're dropping by a factor of 10. Now, after you do this a few times, you don't have to keep showing me your math, but you do need to show me your math down here, because you're going to take whatever fraction you calculate. When you convert that fraction to the decimal here, you're going to take that decimal that you get here, that x, and you're going to multiply x times 1 billion. And that's going to give you this number right here for this. And then you're going to continue to drop by a factor of 10 as you go down. With that is what you're going to have. Now it's going to ask you a couple questions as you do this. For example, what is the highest number well in which some color was visible? Well, if it's well 3, in this example, which I'll guarantee you is not the correct answer, you're just going to read across and find out that it was well 3, and that's what you'd write, well 3. And then, what is the concentration of food coloring? in parts per million? Well, you find the concentration in parts per million, and you read down until you intersect. And if well 3 was the last well you saw color, you would write ppm equals 10,000. Or actually, that's not what you'd say. You would say 10,000 parts per million is what your concentration would be there. But you just read across and down. And then, does the lack of color in the remaining wells mean that no food color is present? Well, think about it. You kept transferring for each one as you went down. Okay, you made this transfer every time, and it just keeps going down and down and down. And just because that you can't see it, the question's asking you, is it there or not? Defend your answer. Which well represents a concentration of 1 part per billion? Somewhere in here, and I'm not going to tell you where because this is part of your calculation, but if it turns out that number 9 is the one where you drop and get down to the number 1 under the part per billion column, then you'd read across and you would say, you know, well 9. But you're not going to know that until you do the whole calculation. And then how many times more concentrated is 5 parts per million than 5 parts per billion? We'll find out, and I'm going to do some erasing here just to clear up my table. Okay, somewhere in here, you're going to have a 1. And if the 1 part per million, for example, ends up being here, read across and find out what the number is in parts per billion. That'll tell you how many more times concentrated it is, or go back and read your introduction. Now, to do the rest of the lab, you're going to look up the health effects by using the EPA criteria air pollutants, and then the calculations. You're just going to go through and do this. The video I have in the chapter overview will go through these calculations, and you'll be fine on that. And that's it for now. If you have any other questions, please reach out to me. Bye-bye.